Okay, so this is where we left off on the last video, and so we were talking about how each polyp secretes a calcium carbonate cup that it lives within, and then over the years, as that individual polyp dies and a new one takes its place, it will secrete a new cup, and then you get this layering and layering and layering and layering, and you can imagine this sort of happening both laterally and vertically as polyps grow. And the building of the coral reef actually involves not just these polyps each laying down a new skeleton, but other organisms actually contribute to reef building as well. And this slide here is a reminder that the actual living tissue is only a thin layer on the surface. So when you see a big boulder of coral, it's mostly all calcium carbonate, which is the skeletons of corals from long, long ago. So if you go down deep enough, you can find coral skeletons that may be thousands and thousands of years old. But as I just said, they're what some people refer to as chief architects, but don't actually do this all alone. So other organisms that can contribute to reef building have to do with coralline algae. Many of these organisms kind of grow in these sheets that can help sort of cement pieces of reef together, especially in the Pacific. You see it a little bit less in the Atlantic and Caribbean and Bahamas, although it doesn't not occur there at all. And over time, you've got the buildup of loose particles. And as I mentioned earlier, calcium carbonate is secreted and produced by many organisms in the ocean, mollusk shells and echinoderm spines and the tests of foraminiferans and sea urchin shells and lots of animals and coral that's died and broken off in the surf. And so you get a lot of particles and pieces of rubble, sand that's produced from just erosion. And all of these pieces can end up being cemented in by the growth of coralline algae as well as other organisms such as sponges. Now we talked about the sclerosponges that secrete calcium carbonate of their own, and many other sponges are sponges that sort of grow over the surface and are encrusting sponges as opposed to just sort of normal upright sponges. So this idea of encrusting on the reef is really common. And bryozoans, which are other organisms that we probably don't have a whole lot of time to talk about this semester, but they also exhibit that sort of encrusting growth. So you've got this coralline algae, these encrusting sponges and bryozoans, and even some other kinds of organisms that can do this sort of cementing process. So all of that contributes to reef construction. In order for reefs to actually grow, you need a hard substrate for coral to larvae to settle on. So we talked a little bit about coral reproduction. Obviously, it happens asexually as polyps grow and bud off into new, and so you get this spreading colonial growth. Pieces of coral colonies can break off. They can be fragmented by physical factors like the ocean. And then a big chunk of coral colony can break off and ride the currents to a different location and settle down and start growing somewhere else. But there's also a sexual reproduction phase, as we talked about. Coral polyps can produce sperm and eggs, and these gametes get shed into the ocean. And there are massive fertilizations that can take place that will develop larvae. And I'm going to put a little video on coral spawning for you as well. But once the larvae eventually sort of swim around and settle down onto a hard substrate, they definitely need something tough, not sand, but hard rock-like substances or precipitated calcium carbonate into cement-like structures for them to be able to grow. And in fact, in areas where they're trying to do some reef restoration, people have put out giant cement balls called reef balls or cement piers in order to try to restore the reef, to re-encourage coral growth. And some of those have been sort of at best moderately successful, lightly successful. It takes a long time for corals to actually grow and take a hold, and there's other complications with using artificial structures for reef restoration. But that's a whole other topic. And again, I might remind you that it was actually Charles Darwin who hypothesized the volcanic origin of the substrate for coral reefs, especially in the Pacific. And it wasn't until many years later that he was proven right, when people had the right tools, like big drills that could drill down like 1,000 feet to actually get through the reef to the original volcanic basalt layer. So aside from the hard substrate, obviously corals need light because of the photosynthetic symbionts that live within their tissues. And so you see them pretty much just in shallow waters. Once it starts to get deep enough, the light attenuates, drops off, and there really isn't enough to keep the primary productivity in a positive direction. So you find corals, of course, in shallow light areas, and as you might imagine, in warm water as well. So the temperatures have to be, somewhere 68 to 95 degrees Fahrenheit, 86 average. So it can be pleasant water to swim or dive in. 80 degrees, actually anything higher than 80 degrees actually feels too warm when you're swimming around for a while. But anyway, having warm water is important for the development of coral larvae. So any colder water can kill off corals. And of course, water that gets too warm, like 95 sounds pretty darn high, and 86 as an average is pretty high. But as the averages creep up into the upper 80s and upper 90s, this global warming of the planet, as you all are very familiar with, also leads to ocean warming. And ocean warming is very much associated with coral death through a process of bleaching. And that's where the zooanthellae are actually expelled from the coral tissue. And so when the corals, so they're not actually bleached white, but when they lose their colorful symbionts, they look very white. So that's a major problem occurring in reefs all over the world, this process of coral bleaching. So they require a certain minimal range of temperatures. When it gets too warm, coral bleaching can occur and has occurred, and it's actually a devastating problem throughout the globe. And in fact, all of the world's coral reef systems are in a pretty severely threatened state right now from a multitude of factors, including ocean warming, but many other reasons that have to do with human intervention and development primarily, and we can talk more about that too. So this map shows the distribution based on the need for warm temperatures. We obviously see them in the tropical and semi-tropical regions belting the equator around the globe. And then certainly with the transparency of the water, the shallowness of the water limits where you can find reefs as well. So there's a fair number of coral reefs, and again, the degree to which they are in danger varies across the globe as well. So when we think about how the reefs are formed in terms of their overall development, here this picture shows the fact that off the island there's often a little lagoon zone and then a reef crust and then a fore-reef zone and then kind of a dropping off into a deeper area. This profile obviously can vary from place to place, the size of the lagoon, the reef crest distance from the island, we'll talk more about that, the slantiness of this slope, how steep it is. I guess I should have said the steepness of this slope. Problem with recordings is that your mistakes, I guess, are recorded forever. And the drop off here, as I may have mentioned, in the Turks and Caicos Islands, is like a 90 degree angle drop down to the ocean floor, which goes to 6,000 feet. And again, the reef stops growing at about a couple of 100 feet because of the lack of sunlight, and it starts to get colder too. So there are three main types of coral reefs, and as we'll see, these types actually represent stages through time. There are fringing reefs, which are close to the shoreline, They grow in this sort of narrow band or fringe along the shore. The original picture that I showed you in part 1 was a fringing reef. I'll probably have that picture again on here. They're close enough to the land, so of course they're the most affected because of runoff from hotel development and human interventions, again, of all varieties. And here's another picture of a fringing reef. You can see it extending outward from the shore. And in Polynesia, these kinds of reefs are quite common and, of course, quite beautiful. And obviously, the lighter blue color shows you the shallowness of the water, and then the little darker areas within that zone can show where there is actual reef. And there's going to be reef patches all through in this fringing reef area. So it's not a solid mass. It's usually patches interspersed by sand and different kinds of reef formations in different parts of the world. The other type that you're probably familiar with, the barrier reef, because of the Great Barrier Reef in Australia, which is so famous, but barrier reefs in general are characterized by the fact that they're separated from the shore by a really deep lagoon. So the fringing reef is right on the edge of the island. The barrier reefs are separated by a shore and by a lagoon, and inside the lagoon there can be little knobs or coral knolls, which are very common in these bigger lagoon areas. And the size of the lagoon, again, varies throughout the world. And of course the largest and most famous is Australia's Great Barrier Reef, which is 1,200 miles long. Enormous reef. And here's a picture of the Great Barrier Reef from above, just probably even just a portion of it. And another shot of the Great Barrier Reef here. And again, this is the reef itself. And there is the coastline of Australia is actually not really shown in this picture, but it would be off to the right here somewhere. Okay. The third type. Okay, so a little bit more about barrier reefs, actually. They have exposed sort of forereef areas, and often there are these sort of spur and groove formations, and so you get coral growth alternating with sand channels. And we see that a lot when we're in the Turks and Caicos. Waves and currents can pile up and make little islands that are called cays or keys. The Florida Keys, Key West, those are islands that formed in this way. Little tiny islands are often referred to as cays or keys, depending on what part of the world that you're in. And so in the lagoon areas, which are shallow already, the sand can kind of pile up along a reef flat and make islands. And this is, again, to remind you of the lagoon zone, the reef crest. If we had knolls, they would be right in this area here. And again, if enough sand piles up, you can have more islands. You could have a little bit of an island form in this lagoon area from that. Okay, probably going to run out of time here soon again. But the third type of reef are called atolls. And these are a ring of reef and cays that can surround a central lagoon. And most of them occur in the Indo-West Pacific region. We don't really see them so much, again, in the Atlantic, in the Caribbean, on this side of the world. And again, that's because of the non-volcanic origin. As we'll see what an atoll is. And here you can see actually an island in the center here that was an island that had grown on top of a submerged volcanic island. Okay, often the atoll just has a central lagoon area, like I just said on the previous slide, and now it shows an island. So this would just be all water, and then the reef would just be ringing this central area of water, but there's been some sand pile up and growth since then. And another atoll here, you can see a little bit more clearly, there's the reef around the outside, and the central lagoon is a little bit more apparent here. And you can tell that it's shallow compared to the deeper water, which has this different color here. Okay, so these three different reefs actually represent stages through time, and this picture kind of illustrates that. A fringing reef is the youngest, as a volcanic island is there. The reef starts to grow along the edge. So what's happening here is the volcano is not really sinking, but seawater level is rising. So the sea level's rising, and the reef, as it's growing, is in the same circular size as it was earlier, but now that this has been more submerged, there's the lagoon that builds up between the reef